In this video, I'm going to show you 3 different ways to represent a relation R that is a subset of A cross A. And so as an example, let's say that our set A is the set 1, 2, 3, 4. And so then A cross A, remember, is the set of all points x, y such that x is in A and y is in A. Now you may see this abbreviated as xy is in A, and that means the same thing. That means that x is in A and y is in A. Now let's say that we're given this relation R, which is a set of ordered pairs, 1, 1, 1, 2, 3, 2, 4, 1, 4, 2, 4, 3. Now this relation R, which is defined by this set of ordered pairs here, this is the first way. This is one way to represent a relation. You can represent it as a set of ordered pairs. Another way to represent a relation is with a graph, specifically a directed graph. All right, so first notice that 1, 1 is in our relation. The point 1, 1 is in our relation. So 1, 1 in R means that 1 is related to 1. And the way we indicate that with a directed edge is an edge from 1 to itself, a self loop. Now let's look at 1, 2. 1, 2 in R means that 1 is related to 2. And the way we indicate that is we start at 1 and we draw an arrow or a directed edge to 2. Now let's move on to our next ordered pair, 3, 2. 3, 2 in R means that 3 is related to 2. So we draw a directed edge or an arrow starting at 3 and ending at 2. Now moving to the next ordered pair, 4, 1. 4, 1 in R means that 4 is related to 1. So we indicate that with an edge like so. An edge that starts at 4 and ends at 1. An arrow from 4 to 1. Okay, 4, 2. 4 is related to 2. Four is related to 3. And so now notice that this is yet another way to represent a relation. If we're given a set of ordered pairs that defines a relation, we can make a directed graph or just a graph of the relation. If we're given a graph of the relation, then we can create a set of ordered pairs. Right, now for the third way that we can represent a relation. And we'll do this with what's called an adjacency matrix. So you can think of an adjacency matrix as a table. It's exactly what it is. It's a table. And the entries in the table are either 0 or 1. They're 0 if there's no edge from one number to the next. And there are 1 if there is an edge from one number to the next. So I'll make this table here. 1, 2, 3, 4. 1, 2, 3, 4. The column on the left, this is where we start. And the top row, right, this is where we end. So starting at 1, is there an edge that starts at 1 and ends at 1? Yes, there is. That one right there. So we put a 1 there. Now moving on to this next entry here. Is there an edge that starts at 1 and ends at 2? Yes, right there. Now moving to this next entry. Is there an edge that starts at 2 and ends at 3? No, there's not. So we need a 0 there. Now looking at this next entry, is there an edge that starts at 1 and ends at 4? No, there's not. Okay, moving on to this row here. Is there an edge that starts at 2 and ends at 1? No. How about starts at 2 and ends at 2? No. How about starts at 2 and ends at 3? No. Starts at 2 and ends at 4? No. Okay. Now moving on to this row. Specifically, this entry. Is there an edge that starts at 3 and ends at 1? No. Next. Is there an edge that starts at 3 and ends at 2? Yes, this one right there. So we'd have a 1 there. Is there an edge that starts at 3 and ends at 3? No. Is there an edge that starts at 3 and ends at 4? No. Now this row. Is there an edge that starts at 4 and ends at 1? Yes. Is there an edge that starts at 4 and ends at 2? Yes. Is there an edge that starts at 4 and ends at 3? Yes. Is there an edge that starts at 4 and ends at 4? No. All right, so that's our adjacency table, which is really just an adjacency matrix. The way we make it into an adjacency matrix is we take off all these things. We go like that, and now it's an adjacency matrix. So now you can see here that here are 3 different ways to represent the same relation. Now, if you ever get an adjacency matrix and you want to make it into one of these other forms, all you got to do is do something like this. And now it's an adjacency table, which you can use to make a graph. And you can take that graph and make it into a set of ordered pairs, and vice versa.